Next topic, we'll start with transition diagram. Before going to the example, first we're going to understand what do you mean by transition diagrams. So these are usually used for analyzing the particular pattern, comparing it and generating the tokens. Okay, how we need to generate the tokens, and for that particular tokens what are the rules are given and how to analyze that particular tokens. So that things can be given by what? Transition diagrams. So recognition of tokens. The regular definitions for the tokens are as follows. If we are having the keywords like if, then, else, the tokens will be generated as same as it is, that is if, then, else. Okay, no change at all. If the keywords is relational operator, the relop means nothing but what? Relational operator. Then the tokens may be lesser than or equal to, or not equal to, greater than, right? Greater than or equal to. So this symbol can be also written as what? Not equal to. Okay. Then ID. So the next keyword I'll consider it as what? ID. Here the ID must be start with what? Letter. Then that letter must be followed by any number of letters or digits. So the star symbol is representing what? Any 0 or any number of times. If I am having single letter, that is also token. Okay, the token of which keyword? ID keyword. And next we are having what? The num as a one keyword. We may have the numeric value. It may be unsigned, signed, exponential, etc. So that we're going to study how we need to draw the diagram for identifier, transition diagram. So that we're going to study in the next example. The next keyword is delimiter. The delimiters are nothing but what? It may have a blank, tab, or a new lines. Okay, so that if the more number of delimiters are present, then we're going to consider it as what? White space. Okay, if it is single delimiter, it may be blank or a tab or a new line. If more than single delimiter, so that will be considered as what? White space. Okay. So the next we're going to start with the attribute value. Here I will consider what? All the regular expressions, tokens here, and attribute values. How we need to get the attribute values for each of the regular expressions. So if it is white space, no tokens are generated, no attribute value. For if, then, else, all three together, the token will be generated as same as it is, that is if, then, else. Okay. So now if it is ID, the keyword is ID, we already studied before, the token will be what? ID. So that is nothing but what? Letter or digit whole star. So it means what? The attribute value will be what here? The pointer value, that pointer to be pointing to what? Table entry. Actually where that particular ID is present in your symbol table. Next is what? If we consider numeric value as num. Okay, the token will be num. The pattern what we studied before, we are having given with what? Some whole equations. Okay, so that is nothing but pattern. Right? So the attribute value can be generated for this particular regular expression is pointer to table entry. Okay. So now if the keyword is lesser than the relational operator, the token will be relational operators, that is given. So now here lesser than, then lesser than or equal to, relational operator is lesser than, equal to, that is lesser than, and this will be lesser than or equal to. If it is equal to, so the token is for this particular keyword is what? Relop, that is equal to. Not equal to, the token is relop. For this one we are using it as not equal to. If relop is, it may be greater than also, so attribute value will be greater than, and relop can be greater than equal to also, so here it will be greater than equal to. I just missed here. So this will be keyword and this will be token. Okay. Now lexical analysis uses the transition diagram to keep a track of information about the characters that are seen as the forward pointer scans the input. It means what we already studied. If we are having the buffer, okay, the buffer if is having two pointer, one is forward pointer and one is what? lexim beginning. The forward pointer is go on scans the next inputs that are given by the user. Lexim is pointing toward the starting of a buffer already started. So the lexical analysis, what it will do, it will keep on tracking all the characters which are present in the given set. Okay, so the transition diagrams are also called as finite automatas. So now the first example, we're going to start with what? Transition diagram for the identifier and the keywords. Okay, so now how we need to write the identifier regular expression. The regular expressions for the identifier is we already studied. So it must start with what? Letter. Okay, then that must be followed by letter or a digit, letter or a digits. Okay, digits, any number of a time, that is nothing but any number of time. It can be given by 0 or any number of a time, that is given by what? Star symbol. Okay, so then now next we're going to draw the transition diagram for this particular identifier. How we are drawing? First, the start symbol, the start state. If I'll consider it as what? Q now. This we already studied. The startings will start with what? Arrow mark. Okay, the previous subject we already studied how to draw the transition diagrams. So the circle indicates what? States. Okay, this arrow marks indicates what? Transitions. The first transition will be, it must be with what? Letter. Okay, so it must be with what? Letters. And the next will be what? I may have any number of letters or digits. Q1 is having with what? Any number of, you may draw here or above, that is left to you. So there is no space, so I am writing here letter or a digits, letter or a digit. Then the next will be what? The next transitions is what? After this. Okay, I may have some characters or I don't have any other characters also. If I am having other characters, then it will go for final state rather than your letter or a digit. If it is any other things, so that will be given it as what? Final state. If it rather than your letter or a digit, it must be written back to the previous character. It must return back to what? Previous character. So because of that, I am using with what? Star here. It must return. For example, from 3, sorry, if it must be start with what? A 3 1 4. If I am having plus. Okay, so A is red letter and any number of, here I am having with what? Digits only. 3 is a digit, 1 is a digit, 4 is a digit. If I am having plus here, plus means what? It is other symbol. Okay, so that time it should return the previous next character. So that is here only the lexims or tokens will get stopped. That is your ID will be what? A314. It is not considered what your plus symbol. Okay, so now that is the case. And so how we need to use the, how writing the functions? Return, where I used two functions, that is, let's tell you, get token and install ID. That is then is having with what? Get token, then install ID. So the get token, okay, this is one function, and one more is what? Install ID. So this is a one more function. See, after getting the token, so up to which token we generated? A31 for this. I took one example. Okay, so after getting the token, we need to install into where? Into a symbol table by using which function? Install ID function. So this install ID functions we are declaring the translation. Okay, previously we already studied 3 things. Okay, and that all in detail we are writing in what? Auxiliary. Okay, so that just go through one more time the structure of a lexical analysis. Okay, so now here those two functions, how it will work. Get token is nothing but what? Return token. If it is ID, then ID means nothing but what? Must be start with a letter or any number of letters or digits. And if it is if, directly it will send that get token. ID, if, else, then what is the value of the token? Same as it is, we already studied the table. Okay, if it is ID, then we need to take that id by using what transition diagram. Okay, if it is looks the symbol table, get token means what, it is always looking for what, symbol table. If it is not there, for example, if is also there, else is also there, then is also there, because they are keywords, so that already present in your symbol table. If any extra ids are generated, for example, I told A314, is it a keyword? No. If I want to do this, I consider it as what, identifier. So now what I need to do, I need to install into an symbol table. I need to install into an symbol table. Symbol table is having all the things, if, else, then, so what are the things, for, that all the things are present. But identifier, the new identifier generated by the user, so that is A314 is not there in a symbol table. So using install id function, so what I need to do, installing the A314 here. That is nothing but, if a keyword or a pointer to a symbol table, entry if id. Okay, if it is id, then I need to enter here, that is A314. Okay, pointer to that particular identifier. So the next, if I am giving with the, so just I need to take the things. If it is input string is for, okay, if I am giving the input string as for, so the get token will be for itself, because it's already there directly. So installation can be done here. No, I'm not doing any installation function. If is there, okay, so get token will be if as it is. Am I installing any install id function here? No. Okay, it is already present in your symbol table, so no need to use the install id function here. Else is there here. If I am, what is the get token of this? Else itself. I don't have to install in a symbol table. Then count is a input string and get token is a id. So count is acting as what here? Identifier. Okay, so now this is nothing but what? Once I consider it as id, so it will start pointing to where? The symbol table entry for what? Count. Num4. Num4 is also acting as what? Identifier. The token of the num4 is what? Identifier. So that is also pointer to the symbol table entry for the num4. Understood? So next we're going to study how that will work, how the lexical will analyzers will work. So here, if I'm writing the program like this, if x is less than 10, then x or else y. Okay, if it is a simple program. If I'm giving this input for a lexical analyzer, okay, so then how we need to consider the set of tokens with then respective attributes. Here, if I'm using if, so if means what is the attribute value? Null only. I'm not writing any attribute value for that. The next is what? Identifier. Identifier is what here? X. Okay, I'm using what? Single letter. Okay, so now id. Here id is pointer to x in a symbol table. Then what is the next thing? Lesser than or equal to. So that is acting as what? Relational operator. What is the attribute value for this relational operator? Lesser than or equal to. The next thing is what? Numeric. That is nothing but number. That is pointer to the 10 in a symbol table. Then, okay, then is nothing but what here? Token. So what if it is a then, else, for, if, the attribute value will be what? Null. So what we studied here previously. If things are, keywords are if, else, then, for, whatever it may be, tokens will be same as it is. Attribute value will become null. The same thing I am showing here. The attribute value for if, then, else, all will be what? Null. Okay, if it is id, that particular id in a symbol table. If relational operator, the relational operator attribute value will be either less than or equal to. Here less than or equal to, or it may be here, if it is less than or equal to, so I am writing here less than or equal to. It may be greater than, that greater than. Whatever things are present in a program, that we need to write here. Okay, then id pointer to what? X in a symbol table. Why? Here I am writing id, right? So one more time, pointer to x in a symbol table. Then else is what? Attribute value will be null. The next symbol is what? Y. id will be what? Pointer to y in a symbol table. So this is the example Okay, for what? Lexical analyzer. This lexical analyzer, or it will take the program in character by character, and it will producing the tokens and respective attribute values also. Okay, thank you all.